Welcome everyone. Thank you once again for joining our TinyML presentation series. Today, I'm very fortunate to have our speakers Aruna and Subi talk to us about the what, why and how of TinyML. We'll probably go more into the demos and explanations, and the good thing is Aruna is going to talk a little bit about federated ML and how it can be applied and the differences between that and TinyML. But before we get started on the presentation, some key things we'd like to cover. And that is, obviously very important for this to move forward or for this to progress. We have some key sponsors, right? And some of the key sponsors here being ARM, who I know we're actually doing some good work with as well. Edge Impulse, Kexo, Reality AI, SensiML, SynSense, Qualcomm, Maxim Integrated and DeepLight. If you're willing or if you'd like to sponsor these talks, please contact Olga at tinyml.org for further information. I know myself will be sponsoring TinyML, and I'll be actually organising this once this presentation is done. So please feel free to contact us if you're interested in sponsoring. A big thing and something which let's go back one. One of the key areas, or one of the, I guess, initiatives that's on at the moment is a hackathon, a vision hackathon. Gone too far forward. Apologies. There we go. And what this is there's a TinyML vision hackathon. Submissions are accepted up until the 15th of August. So if you've got a cool idea or something you want to explore, we're going to see one actually today during our presentation. Winners will be announced on the 1st of September. And you can win, up to 6K. So if you've got something that you'd like to explore and possibly get some money, if you think it's something that's of value, please submit. The link is there. We're considering about submitting something ourselves, but look forward to seeing some of the great initiatives and some of the great ideas and innovations that some of the people are watching through this. The great thing is we also recently ran the TinyML Summit 2021. If you have a look, there's so much content and materials. I know I've been jumping online, going through YouTube and looking through a lot of the videos. Really, if you haven't had a chance yet, jump online. Everything's available. There's also the summit coming up in January of next year. Hopefully, with everything going well up in California. But there's definitely, if you're interested in getting involved, let it be if you're in academia or if you're in business or if you're in enterprise-based systems. Have a look. There's definitely some definitely interesting presentations, and get involved. Oh, going too fast. The next forum is actually in Europe. So deadlines for abstracts have already been closed, but it's going to be live. So TinyML Technical Forum. If you're interested in being a sponsor, please click or look at the link below and let the team know as it's still open for sponsorships. But further ado, let's start introducing the speakers. So Aruna, who I know myself have done a little bit of work together, is the Chief Technologist for AI at Dell. She's got a lot of experience, over 20 years in the industry, including AI, deep learning, computer vision, blockchain, IoT. And she's also worked with IBM in big data analytics with Oracle, so has a lot of experience in the whole middleware and enterprise architectures. To support her as well, Subi is presenting, and I know I work with Subi closely. He's helped us with a lot of AI innovations. We recently did a huge hackathon with a big customer in Europe using some Dell infrastructure, which did the core processing. But this is how we see us working together, right? We do some TinyML processing at the edge and then core processing on a server or on the cloud in the future. But he's got some performance tuning experience, S4 SAP experience, Oracle technical architect, over 15 years, and definitely supports global and local rollouts. So thank you both for presenting, and I'll hand it over to you to start the presentation.
Thanks, Dr. Nick. Thanks for the introduction. And today we are going to take you through the basics of TinyML. I know some of you might be familiar with it. Just hang on. We have a demo at the end as well for something relevant in this region, what we have faced in some of the disasters. So just to start with the evolution, right? Over the last decade, we have machine learning evolving. We have machine learning in the data center. It's been used for a long time. We had these large models in the data centers, which we have been using. And then we wanted to bring that intelligence to the emergence of our mobile devices, right? Whether it's smartphone, laptops, and all these different things. So we actually, sorry, can't see it anymore. Sorry.
Yeah, it's back again. I don't know.
Yeah. Yeah, it's actually bringing that intelligence to the mobile devices, right? So we had the machine learning models come onto the mobile devices. Now it's actually going on to microcontrollers. It's an evolving area, but it's been really growing very quickly.
Aruna, Subi here. If I may ask for the general audience here, just to understand, as you know, the buzzword going on is in the market at the moment is federated learning, and how do we differentiate federated learning versus TinyML? And the other part to the story is, can we actually train these machine learning models at the edge? Is it considered as federated learning? So, can you give your feedback on what do you think on these questions?
Sure. Just before we go there, I don't see the green square around my screen. Can you see my screen?
Yes.
Okay.
Yep.
I don't see the green thing. Okay, fine. So federated learning is different from TinyML, right? TinyML is for inferencing on very small devices. When we are talking about federated learning, we are talking about training the data where it is without bringing it to a centralized location. So what happens in federated learning is, for example, if you have your mobile phones, you have your pictures. If it's on social media, it can identify Subi, you, me, and Dr. Nick, and everyone else on your phone, right? So that's how it's doing is it's taking all the images from all our phones to a centralized location, training the model to identify all of us and sending it back to our phones. But federated learning is about training it on the mobile phones itself. So my phone will train how I look like, and your phone will train how you look like, and Dr. Nick's phone will train how he looks like. And these models will actually be brought together into a centralized location, and a common model will be built, or a global model will be built from these models and sent it back to the mobile devices to identify all of them. So that's federated learning. We are not sharing the data there. That's the key. And that's how we actually share the whole, that's how we train the model. But here it is different, right? Here we are talking about inferencing. We are not talking about training. We're talking about inferencing on very, very small devices or microcontroller units.
Right. So actually, when you create these small inferences or tiny inferences, can you train them at the edge as well using TinyML algorithms?
No, we are not training at the edge. It's just inferencing.
Okay.
I mean, in terms of the algorithms, we'll get into the details a little later on in the slide there.
Yeah.
So TinyML is like a intersection between IoT or embedded systems and machine learning. In other words, you can say that it's a technology that can be used to develop embedded low power consuming devices to run both machine learning and deep learning models. So it can be implemented in low energy systems like sensors or microcontrollers or small devices, right? Where it doesn't need a lot of memory or power, and it can actually run on very, very low memory and power consumption with very low cost. So the challenges here are it's really cool, right? Like we can actually run everything, low memory, low power, low cost, everything. It's really cool. But what are the challenges, right? Models in general are getting really large. For example, if we take GPT-3, that's the OpenAI's transformer model, it has 175 billion parameters. It's actually 17 times larger than its previous model. They're just getting larger and larger. We don't have the numbers for GPT-3, but I've actually read it that the 345 million parameter GPT-2 model needs around 1.3 GB of storage just to store its weights, and running inference with TensorFlow actually requires about 4.5 GB. Right, so these are the requirements of the models. Here we are talking about very small microcontrollers with few KB of memory or few MB of memory in there. So it's literally impossible to run these large models. So we need to think how we can reduce these models and the footprint so that we can run it on these small devices. Why do we need this? We see microcontrollers all around us today, right? Microcontroller is actually a small special purpose computer that can actually perform a task or a program within a device. So we actually see these microcontrollers everywhere in our offices. We actually use keyboards, monitors, printers, and all these different things. At homes, we use, they are in part of our microwave ovens or washers or dryers, security systems, all these different things, right? Our entertainment units. Many of these things actually have microcontrollers in them. And we want to have these deep learning or machine learning intelligence brought to these machines using those embedded devices. And we want to run on very small, inexpensive chips, and which can run on batteries. So again, coming back to why we need TinyML, right? Like the three different factors, the few different factors, performance, right? Because the reduced optimized machine learning algorithms in TinyML can run on edge computing, and the data processing is really efficient. Only necessary or desired data, like if at all it is required, is actually sent it back to the server, but in general, everything happens at the edge. Data transfer takes time, and that's actually the delay. So this happens in the edge, so we don't have the delay. And the second one is the energy savings. Microcontrollers are they actually hold these TinyML models. They have very low energy requirements, and they actually reduce charging length and frequency. And so transferring information requires extensive server infrastructure. When there is no data transmission, again, energy and resources are saved, and subsequently the cost itself, right? And no connection is required. We don't need the data to be sent to the server and inferred it and then bring it back. So we are not depending on any connectivity or the cost. It's actually deployed on low cost devices. We are not running on GPUs, or we are not trying to get high compute servers there. So it's really low in cost as well. And the data security, right? So you're not, again, for reasons where you don't want to really send the data to a server for inferencing, and you want to keep it really private, you can actually do the inferencing at the edge on small devices. So these are some of the reasons why we need TinyML. We are talking about...
Aruna, I've got another question here. If you can help us understand a little more of it. How are these normal machine learning models different from the TinyML TinyML models? And do we need a separate data set to train these TinyML models or algorithms to be created to train these models? And if you can shed your feedback on what do you think on these?
Sure. Thanks, Viva. That's actually a very good question. Right. Again, this is not different. Like, it's the same algorithms. What we are trying to do is actually compress the models and utilize some of the frameworks we already have within in the open source to really get those models to a smaller size, right? So it's all about compressing the models to a size where we can put them onto the device. And also this compression helps in reducing the manipulations or the calculations, mathematical calculations on the device itself, reducing the power and the memory requirements.
So when you compress a model, does it impact the accuracy of these models compared to normal models?
It does to a little extent. It depends on how you do it. There are a few techniques on how you really achieve similar accuracy on these devices, right? Here again, we have to remember we're not having a GPU server for inferencing here. Yes, there will be a little accuracy difference. It might be, right? It's not will be. There might be a little difference in the accuracy, but it also depends on how you actually compress the model as well. So let's actually see a few of these, right? So when you think of the TinyML model, you said, do we actually have a small model? No, we actually train a larger model. We actually make it smaller, right? So for running it onto the cloud, we actually optimize it. And then now when you're running it on mobile, we have even more optimization, and we have all these frameworks like TensorFlow Lite or PyTorch Mobile, which is recently released. All these algorithms or frameworks really help you to compress the model. And we also have new frameworks again for deploying them onto the microcontrollers, right? So we'll go a little deeper into the frameworks as well. So when we're thinking of compressing the model, the goal of model compression is actually to achieve a model that is simplified from the original without really significantly diminishing the accuracy, right? So like you said, Subi, we don't want to reduce the
accuracy
completely, but like we want to see like how we can compress it at still preserving as much of accuracy as possible. So these are some of the methods for compression. One is pruning, quantization, and knowledge distillation. We'll go into the detail of each three of them. Pruning, it's literally pruning pruning different components within the neural network, right? You start with the trained model and really cut or remove some of the connections which don't have a major effect on the final accuracy. So the resulting model is a prune model, which has much fewer parameters, and there are a few design choices involved here, right? One important decision criteria is actually on certain filters. If certain filters are removed while others are retrained, like how will it really affect? Another crucial factor is the level of pruning to which it is done, right? How much you want to prune. So there are multiple different kinds of pruning, right? Weight level pruning, as you have seen, the majority of trained weights in a certain neural networks are not really helpful, not all of them. If we can identify those weights, we can actually contribute to network accuracy. Which don't contribute to network accuracy, we can keep those and really remove the rest of the weights which don't contribute to the accuracy. And then we have node level. One at the level of the individual connections between the neurons, and the other one at the levels of the nodes itself. We can remove some of the nodes which don't contribute to the accuracy gain, right? So yeah, again, there's layer level and the block level. Block level is typically, you can actually think of it as layers are typically combined into reusable subgraphs, and these are called blocks. And you can remove them as well. You can think there are different ways of pruning the network, depending on the use case and depending on what parameters are used and what are not used, you can actually prune it. And the second one is the quantization, right? It's again, it's a very simple one. Just to simply explain it, you have all these floating point numbers, which actually require a lot of storage. And we also have matrix multiplications on these floating point numbers. We all know it takes a lot of space and it takes a lot of memory to really process those numbers. So just using something like some algorithm like k-nearest neighbor or something like that, and then bringing them to int8 kind of a format. So it really reduces the amount of storage required to store the integers and also the mathematical calculations, right? So simply, these are the two ways of doing it. If we actually experiment these techniques, you don't have to implement things from scratch. TensorFlow has things like TensorFlow Model Optimization Toolkit for TensorFlow Lite, and even PyTorch is coming up with PyTorch Mobile, as I said. So these are some of the techniques which you can use to really reduce the network, make it smaller, and deploy it onto the embedded devices. These are benchmarks from TensorFlow Lite documentation with quantization methods and the performance in TensorFlow Lite. So performance also depends on the hardware you're using, right? A network quantized to integer 8 will actually perform so much better on a processor specialized for integer calculations. It also depends on what hardware you have, and you have to choose the right combination to really quantize your models. The third one is actually the knowledge distillation. It actually refers to the idea of the model compression by teaching a smaller model or a simpler model, which is the student network, step by step exactly what to do using a bigger or a complex model, which is the teacher model, right? Teacher network shares the soft labels, which are the output feature maps after each convolution layer. The student network is then trained to learn the exact behavior of the teacher network by trying to replicate its output at each level. So ultimately, the student network can achieve an accuracy that would be unachievable if it is directly trained on the same data. So the same accuracy can be achieved with smaller models or a simpler model, right? This is usually expressed as like some shorter running time or other things like that. So any questions
Subi here, Aruna. How do you include these techniques into the algorithms? Like, I mean, if for example, a use case requires quantization to be included, do you need to edit the current codes, or how do you do it?
You can actually edit it, or what you can do is actually use some of these frameworks which are there. Right? We don't have to implement all these techniques from scratch. We have these frameworks which will help us with compressing the models for embedded devices. So TensorFlow Lite, it's actually an open source framework by Google. This framework is for inferencing on embedded devices. It has two components. One is actually the converter, which converts the TensorFlow code into that compressed format, reducing the model size and optimizing the code for minimal accuracy loss, like you asked earlier. And there's also an interpreter, right, which allows to run the code on the embedded device. And then a separate port of TensorFlow Lite called TensorFlow Lite for microcontrollers is actually designed to run machine learning models specifically on 32-bit microcontrollers with just a few kilobytes of memory. So, and then we have Embedded Learning Library. This is actually an open source framework from Microsoft, and it really helps developing machine learning models for platforms based on ARM Cortex-A or ARM Cortex-M architectures like Arduino or Raspberry Pi. And then we have ARM and an SDK. It's actually a set of open source Linux software tools that really enables machine learning workloads on power efficient devices. This inference engine provides a bridge between existing neural network frameworks and power efficient ARM Cortex-A CPUs and GPUs. And recently, Facebook announced PyTorch Mobile, which is actually in the beta phase now. So there are frameworks already there. You don't have to edit the code, but you can if you want to make it more efficient and small. So we actually went through very quickly about what is TinyML and why we need TinyML, right? So let's actually look at some of the use cases. TinyML actually has a lot of potential in multiple industries. These are some of the few industries which I'm talking about here, but in general, there are a lot of use cases we can use it for. So TinyML has a great potential to really improve monitoring personal health devices, right? So whether it's wearable devices which use a lot of power to continuously sense and actually stream the data, right? A compact pre-trained inference models which can be put onto the wearable devices itself, actually on TinyML, can provide a very comprehensive assessment of person's data in real time and not have to stream the data to a centralized cloud or a server. So many healthcare manufacturers are exploring ML type frameworks to enhance various personal health products like hearing aids or wearable watches and things like that to get a lot of details from the people. And then similar trends are expected for other personal health products or even well-being products like vision enhancement or gait tracking, like how you're walking and everything. And combining data from multiple sensors. Again, it's not just from one sensor, but how do we actually combine the data that's coming from multiple of these sensors and use a deep learning neural network to really inference on an embedded device with enabling really continuous monitoring and assessment of a person's well-being, might actually help for really looking at the mental health and improving ways to treat these people having these conditions, mental health conditions. I think it really helps in the current situation with the pandemic where we are predicting that there'll be a lot of mental health issues. So having those in some in our wearable devices and monitoring the health becomes a key. Then we have surveillance, right? Object detection, person detection, face detection. All these are simple activities where that's we actually think of when we are thinking of surveillance. These examples of tasks can be performed with high accuracy running TinyML based code on, again, microcontroller units, which are microcontroller units, right? So TinyML will enable the development of new type of low-cost surveillance monitoring and recognition applications. And then the industrial monitoring. We are witnessing the rapid development of industrial internet practices seen through advancements in the automation of traditional industrial segments, enhanced connectivity, and smart sensing technology. So TinyML is well positioned to support further enhancements of these practices in many industrial monitoring applications, whether it's predictive data analytics that can be embedded and implemented within the devices, or TinyML can address the needs for in-place data analytics and time-critical constraints of some industrial monitoring applications, right? So, and again, indoor localization services for asset tracking can be designed based on neural network models with RF signals input. And there's immense possibility in the industry monitoring. In transportation, if we can apply TinyML to sensors ingesting real-time traffic data, we can use them to route the traffic more efficiently and reduce response times for emergency vehicles. We can use TinyML on streaming data to really improve passenger safety and reduce congestion and improve efficient routing and things like that. And then we have smart factories in manufacturing sector. TinyML can stop downtime due to the equipment failure by really enabling real-time decision making, and it can alert workers to perform preventive maintenance when necessary based on the equipment conditions. And then in retail, we can actually monitor the shelves in store, sending immediate alerts as the items are not present on the shelves, and look at the shelves to really monitor how many are there, how they have to restock it. Agriculture, farmers have severe risk of profit losses when their animals are at illness. So having these wearable devices on livestock to monitor the health vitals like the heart rate, blood pressure, temperature, just like what we do for the humans, can really help predict the onset of the infections or any diseases within the livestock. And the last one is disaster. This is actually not a comprehensive list. These are a few examples of what it can do. There's enormous possibilities of what we can achieve with these models. The last one, disaster prevention. I just wanted to go and show a little demo on that. So here in Australia, we have seen bushfires year before last, and it was really bad, right? Like we had these large fires which we were not able to control for a long time. What if we had information about the fires when they were really, really small? So I thought about how we can use this tiny devices, right? So we're talking about models running on battery power. And I was thinking about bush, right? There's no power there. There's no resource or electricity to actually plug in a server and to detect fire. But these kind of devices will really help us, maybe putting in some fire restraint boxes or things like that, and having this camera and detecting the fire when it is really small will help us really get to know when the fire started and stop it before it becomes really large. So just to show a quick demo of that. So I'm actually using this OpenMB camera with a microcontroller unit. It comes with the camera itself. I just picked this one. This is really cool to start some of your projects or concepts if you want to bring it to life and see how it works. It's really good to start with. And what I have here is I just ran the one which identifies whether there is fire or whether it's safe. So what I'll do is you can see it showing safe, and I'll just point it out to another monitor which has an image of a fire. So I actually have a video of that. So you can see it can identify the fire, and then when I take it off the fire, it shows it's not. You can see the performance, right? It's quite good compared, considering the size and what it is doing, and the latency as well. So this is something which we can actually use to figure out any kind of disasters, not just fire, whether it's smoke or anything. We can actually have these cameras look into what's happening and then really get to identify them before it really becomes a big problem. The other one is actually in the bushfires, in the same bushfires, about 1 billion of these animals died, right? Like kangaroos, koalas, all of them, 1 billion of them died. And after that, they were trying to rescue, right? What they were trying to do is actually send a drone to really see where the koalas are. And I don't remember the rate, but it's actually, this one is so much more efficient than people manually spotting, right? This, I think it's about 20% more efficient than the trained koala spotters, right? They are, and it's really hard to spot a koala in the bush. And what they were doing is they were actually sending it the drone and then manually looking at the monitor when they were operating the drone to really look where the koalas are to rescue them, right? So this can be, again, I thought we could use TinyML again to get to see like if there is a koala in the bush and really see if we can get the drone to be automated, right? Have this camera within the drone itself and then automate it to check if we can detect the koala and then maybe hover over there to really see and stop, right? When the whole thing can stop when the koala is detected and send the location so that we can actually go and spot it. So again, this is another little demo. So I have a little box here with a koala and a kangaroo. So you can actually see, sorry, you can detect the kangaroo and the koala.
Just a quick question, Aruna. What hardware are you actually using? What kind of what's the vision device that you're using?
Sure. So this is actually I'll stop sharing so you can see the video in a bigger mode. And then, so here, this is actually the OpenMV camera. It comes with the microcontroller unit and the camera itself together. What you have to do is just plug it in to any of your maybe Raspberry device or anything, right? Or you can embed it into any of the embedded chips or machines. But here I'm just connecting to my laptop to get some power and show you the console there. It's just reading, and it comes with a set of bunch of demos as well, the person detection, and quite a few demos on the chip itself. And it has about 32 megabytes of memory on there. So you can actually pull in both the models right now. They're about 700 kb each. I've just put them on these ones, and then I'm running it from here.
Thanks.
I'll actually stop here for a few questions if you have, and then.
There's been a lot of questions, Aruna, but we're trying to. I think everyone's trying to help answer as well as they're coming up because they're coming through. So one of them was actually what's the hardware. So we've got that one answered live. Is that an OpenMV camera? Yes, it is. So we can say answered live. If you need to start on the TinyML today, what microcontroller would you suggest? So you recommend the OpenMV. I've actually had a bit of a play. I've got one over here as well. This little device here called an ESP32. It's a little device as well. It's got a USB micro USB slot in there, so you can plug it directly into into your computer. But there's numerous mini devices, and again, we're looking at these things which are quite low powered, right? So I know I've also got Raspberry Pis, but the bigger Raspberry Pis obviously consume a lot more power. As Aruna demonstrated in this demo, this is for being out in the forest and where you could hook up a solar solar panel to it and hopefully just live off power. I mean, we've got a few examples. We've done one, I know, with SAP around forest monitoring where we've got, solar powered devices out there listening for chainsaws to identify if, trees are being cut down. So there's definitely a lot of interesting things. So,
Yeah.
there's a question on costs. These things, depending on where you buy it from, I bought mine actually from Alibaba. Like they're like $5 or $8, depending on which vendor you get it from. How much is the OpenMV? How much did you pay for that one?
I think it's about $120 or something.
Oh, wow.
Because it comes
Okay.
with the camera. And and actually I had to get this from US. Maybe that's the cost difference as well, right? So
Yeah,
the
sure.
dollar difference as well.
Yeah.
But again, there's lots of these things, right? It's not just these ones. If you have a little bit more power, you can actually use the Jetson Nano or specified ASICs like Jetson Nano, which has a processing unit there, or TensorFlow GPU, so Google TPU, Coral TPU board, which has again a tensor processing unit, and or Intel's neural compute stick, which comes with a vision processing unit. Depending on what you're doing, if you have a little bit more power, like you said, like people were asking, we can actually use those as well, right? So again, these algorithms or these techniques can be useful for any of these, because we want the algorithms to be smaller in any case, right? We want to be more efficient using less power, even when we are running on web servers. So, so if you have a little bit more power, there are a range of things. These are things which can be embedded into other devices, but if you have an individual one which you want to run, TensorFlow TPU or Vision neural compute stick, Jetson Nano, Jetson Xavier, there are quite a few of these devices which we can use.
Great, thanks, Aruna. I think there's some questions on what models did you use as well? I'm assuming I think you said you were using PyTorch, is that right? Or were you using TensorFlow Lite?
Yeah.
Okay. Yep.
Yeah. So I was actually using MobileNet SSD from TensorFlow Lite, and I used the TensorFlow optimization toolkit to make it smaller.
Okay, great. Questions on what is the false alarm rate for, say, koala or fire detection? I guess someone wants to understand what are the,
false positives.
Yeah, false positives. Yeah.
Sure. So this will not be something specific to TinyML, right? It'll be in general, like what are the false positives? It depends on how you're training your data. If I actually train it with this one, it's very small. I just trained it on like 25 images. I just had this two things, and then koala and the kangaroo. But the fire one, I had a lot more images, right? I had a lot of fire images and a lot of images which don't have fire, right? Like the houses or forest and multiple other things. So the accuracy rate I got was, I think, around some 88% or something like that for the koala and kangaroo one, and the other one was 92 or something of that sort. But again, it depends on the size of the data set you use, the quality of the data set, and then how you're training it.
Great. There was a question on TinyML and what's called ESP32s and cameras. Actually, I've got my little module here. If you have a look, it's a little ESP32.
I'll stop sharing so that will become larger.
Okay, no worries. No, I've got a ESP32 with a camera on there. Again, depending on the clarity and capability, OpenMV is obviously a lot more better quality camera than an ESP32. But depending on the project you need, you can get things done. So hopefully that's helped with that answer. False alarm rate, we've done that one as well. And how much TinyML is able to be done on a single core? Okay, so that one's an interesting one. I know my ESP32 is a dual core ARM. I'm not sure about the OpenMV. Do you know, Aruna, what kind of
no, I haven't really looked into that.
Yeah, and I think there's the predecessor to the ESP32, the ES 868 or something. It could do basic, capability, basic ML processing as well. I've seen it used in another project, but again, depending on what you want to do, really is how much you want to be able to process, right? I think audio processing probably won't be as complex as image processing. So it all depends on what you're trying to achieve. So hopefully that helps with that one. Flying through answers at the moment, but hopefully I've helped answer most of the answers there. If there's any more, please keep Hold it. There's another one that's just come in. I'd like to clarify about what you said using TensorFlow Lite for training. Do you mean TensorFlow Lite Micro or just Lite version? I'm using TensorFlow Lite Micro version, so I wonder if any differences between these two. I'm not sure on that one. I'm not sure if you've had experience with that either.
TensorFlow Lite Micro is actually for microcontrollers. So if you want a very efficient, optimized model, yes, TensorFlow Lite for microcontrollers is the right one.
Okay, great. Cool, done that one. And how well does TinyML work with MicroPython? I haven't had a chance to play that one.
Yeah, it's actually TinyML works with MicroPython really well, and that's how it's built. It's built for that, so it works really well.
Okay, and is the model pruning performed on the edge? No, I don't believe so. I believe the pruning is done server side, but I'll get you to.
Yeah, once we actually train the model and prune the model, sometimes what happens is it's an iterative process. You prune it and then you go back and retrain it as well using those weights. So it happens at the server side, and once you have a final optimized model, that's when you place it on your edge device.
Mm-hmm. Yeah, no, that's good. And have you? Well, I haven't tried the Raspberry Pi Pico. I know that sold out as soon as it was released, but I'm not sure if you've had a chance.
No, I haven't had a chance to look at that as well.
Yeah. Okay. No worries. Yeah, unfortunately, Vladimir can't answer that one, but it'd be great if someone has. Feel free to add in. Great.
Yeah. So just to say how Dell can help here, now we need to build a larger model. What we have seen is we actually build this large model on the server, and then we optimize it to make it smaller and put it onto your microprocessor or the embedded units. What Dell can do here is, or Dell is doing here, is actually we have ready solutions, right? So with multiple partners, we do have ready solutions, ready solution for AI, and ready solution for with DataRobo. What it does is it actually comes as a complete box, right? It comes with storage, server, networking, frameworks, open source frameworks for ready solution for AI, and whatever solution is mentioned on that slide for that particular solution. And it actually, what you have to do, in the ready solution for AI, you actually go and say, I want to use a particular framework, TensorFlow. I want to use 3 GPUs for so long, and you just click on that and you have your Jupyter notebook ready, right? So you don't have to think about what storage you'll need, what hardware you'll need, what software you'll need. Everything is actually built into one box. So you can use your time efficiently on building the models rather than cobbling all these bits and pieces together.
Aruna, so maybe share that slide.
Sorry? Yeah. I was going to say, I think you've got that in. I think you've got that in the slides. So share that out. Yeah.
Yeah. Sorry, I stopped sharing to show the video, and then.
It's all right.
Can you see it now?
Yep.
Yeah. Yeah. So these are the different solutions we have. We have ready solution with Cloudera, H2O.ai, Guazio, ThoughtWorks. We have quite a few of these, which we have built for the customers. And for some of those, if we don't have a solution out of the box, we do have different architectures. We have worked with multiple customers to build these solutions for customers. So what we have is actually different architectures here. So we have different architectures for multiple of these things. You can actually see H2O.ai, Guazio, Kubeflow, and in the AI ML side, and even on the data side of things, how we actually manage the data lakes, how do you do the data analytics and streaming analytics, a lot of these, right? In different areas, we do have expertise. Subi, do you want to add something here?
No, guys, if you guys have any use cases, because all will depend on what use cases we are trying to implement here. So depending on what use cases we are looking at for customers, then we can pull in the reference architecture and can implement it, help you implement it. If there is a proof of concept required, we do have the entire platform which can be used for those proof of concept or use cases implementation. So yeah, please get in touch with Dr. Nick, myself, or Aruna, or the team here. Certainly be able to help here. And just to, before I forget as well, if there is a AI ML use case on a customer who is running SAP, so we can help there as well. So there are, between Dr. Nick, who works for SAP, and us, we work for Dell Technologies, we have got that stronger and formidable partnership where we can implement an end-to-end scenario, what you guys are looking for as well. So, yeah.
More questions have just come through as well. Would TinyML work, what's it called, M5 stack series? I'm not sure what the M5 stack is, to be quite honest, but if anyone else knows, please feel free to answer that question. But I'll be honest, I'm not too familiar with the M5 stack.
Yeah, I haven't come across it either.
Yeah. Would TinyML work on incremental federated learning machinery, partial part device data where device data is not shared at a central level? Yeah, definitely. I think that's one of the benefits of TinyML, right? That we you can keep data at the edge, and this is one of the beauties of federated ML. I think I shared in the link. Google have a great example, and one of the reasons why federated learning is important for them is the whole privacy idea, right? That rather than sending all the data back to the server, you're sending a subset or just the score data from the edge to the central server to be able to process. So, that's definitely that's what, and that's actually something that I'm working on at the moment around predictive maintenance and sound at the edge. So, definitely, it's something that we're doing. So answered that one live. Since TF Lite is open source, what specific help can Dell provide, guys?
Yeah.
Aruna, you can take that one.
Yeah. So we can't really build a small model, right? We actually have to build a model. We need data platforms for that. We need training and for servers and the compute and the networking and everything. So what we bring in is actually how do you build that larger model to actually make it more efficient? And we work with open source tools and the software to really get there.
Yep, great, thanks.
And the next question, like Dell selling hardware or software, I'll just extend this. It's just an extension. So we actually sell hardware. Dell is a hardware company. And again, what we have is a lot of partnerships with the software vendors as well for specific solutions. Whatever you have seen, some of the solutions we can resell. So it comes as a bundle.
So what Aruna showed in one of the previous slide, guys, is the reference architectures with different partners, what we have established. So to be able to implement a use case, you need a platform. And that's, so generally you don't, although it's hardware underneath, but it's a platform which provides more capabilities than a hardware. So that is what we are talking about. So it's a combination of hardware, software, which we call it as a platform. And we work with partners to implement their solutions on that platform. So that's how Dell can help.
Great. Do you have a full hardware stack for a smart home network? I don't believe so, guys, but I'll let you answer.
Full hardware stack for a smart home network, depending on what you mean by smart home, right? What you want to implement. Happy to have a chat to understand more about it.
It might be a bit. It's alive. Can anyone recommend resources that we can use on learning TinyML? Yeah, I guess that's a good question. What did you use, Aruna, to start your TinyML journey?
The TinyML YouTube channel, right? There's heaps of talks on there. I went to quite a few of them, and then that's how I actually picked up the OpenMV camera, and then started working on it. And then for me, I really jump onto things without reading the manual. That's how I learn, but there is a lot of documentation available as well.
Great. Thanks, Aruna. Is model pruning capability available on the platform? Well, it depends on what platform you're talking about. It's definitely available in TensorFlow Lite. I think that's what you mentioned.
There are frameworks.
Yeah.
Open source frameworks have it.
Yeah. Okay. And I know someone asked about solutions. There was also partners that do that as well, right? So have a look at our partner software offerings, because they also offer some of this as well, some of that capability. Thanks for answering my queue. Does Dell also manufacture custom hardware using TinyML? Probably not at this point, but I'll let you guys validate that one. Yeah.
Custom hardware using TinyML. Yeah, as you said, it's actually in the very early stages, so we should be getting there.
But Yep, exactly. Like, I mean, we can certainly work on it if there is a use case or a thing to work on, which is nothing stopping us from doing that. But yeah, not yet there is anything readily available on TinyML on our platform.
Great. Well, I think there's been there's a few more smart home dashboards with multiple devices streaming. I've seen some of that, but I don't think with data streams encrypted at the edge yet. That's probably
in short, Radu, I can. So Aruna, you can add as well. So yes, all those your requirements, what you have mentioned, can be addressed. We can put together a solution for you. Aruna, you want to? Because
Yeah.
I know, Aruna, that you work with Daniel and all to put together some surveillance solutions. So
Yeah.
maybe, yeah.
Yeah.
Yep.
M5 stack, like we have not, I have not come across it yet. So
No,
I don't have
unfortunately, I
experience
know
with
that
that.
was
Sorry.
coming with that one.
Somebody answered it before, saying that M5 stack is not supported. Somebody answered it before
Okay.
from the audience.
Okay. And I guess the other thing people are asking, this will all be on YouTube, right? So the recording of this, if you want to review, have a look at what's been done. That and the slides will be available on the TinyML forum site. So good. Okay, so maybe with that, we'll hopefully people have answered the questions which were asked. And maybe the next thing is to then move to the next slide. If we've already done that.
Should I go to the next slide?
Yeah. Okay, so thanks again. As there was a lot of questions actually about. Oh, let me go back one. Maybe because I hit it and you hit it as well, Aruna. We're both trying to be efficient and effective. As mentioned before, Quexo, Reality AI, Edge Impulse. If you're looking at doing some of these models as well as what's out there with open source, there's already some solutions in here which will help you or help you manage the models moving forward. So have a look. And again, if you're interested in sponsoring, please contact Olga. She'll have, she'll be able to give you the best support and identify how you can help sponsor one of these presentations. Next one is on another partner, which is ARM. And I know that we're actually in fact, I think we've got a meeting with ARM tonight, talking about their platform and offerings. Go back. So there's definitely different things that are available. And one of the interesting things I actually learned with ARM is some of the work that they're doing in 5G, the ability of actually running, I guess, the models at what we call the RAN, actually on the radio. So definitely some interesting things to look out for, and definitely one of the sponsors. Next one, DeepLight, basically make other AI faster and more efficient. One of the people who asked, is there any solutions? Have a look and have a play and see how DeepLight works for you regarding making your models available. Again, more tools. Edge Impulse gives you the whole life cycle from device, embedding at the edge and tests. So, again, more of these sponsors. Have a look. There's, as we mentioned, there's many different libraries available to you, and pick one that suits you and basically suits your needs as well. If you're looking for integrated, Maxim Integrated have some hardware capabilities which allows you to integrate your solutions, and definitely in health and some of the other areas, but definitely there's custom modules which can be built and developed for you. And Quexo AutoML allows you to use basically training and everything at the edge, right? So there's, again, we were looking at people asking before about what can they use to help, I guess, simplify or produce some of these tiny ML models. there's solutions out there already available for you. So if you like, have a look at the videos as well. Everything, I believe, these are sponsors that have presented at the conference. So please feel free to have a look. And Qualcomm as well, obviously big research going into Qualcomm, especially around the embedded devices, everything from IoT, industrial IoT, automotive, and mobile. I think there isn't too many devices out there that don't use Qualcomm, especially if you're looking at the 5G space. Qualcomm's probably a leader in that, especially around their mobile radios. And Reality AI, so pre-built capabilities for sensing modules. So let it be sound, industrial anomaly detection. I'm going to look at this in a bit more detail as things are coming forward. So have a look at our sponsors. And SenseML for smart IoT data. So again, AI code, end-to-end AI workflow, multi-user. So this is where, if you're working in teams, some great things. But and I'm already seeing some people put some great comments in. So thank you as well for participating. And Sense as well. So builds sensing inference hardware for low devices. So if you're more into the hardware builds, have a look at Sense to do that for you. And that's it. So thank you once again. Please, if you have any questions or any further, please feel free to contact us directly. Aruna, Subi, thank you once again for your time. I really appreciate it. Some great demos, some great examples of what we can do. I'm looking actually forward to working with you both. Hopefully we can do something great in the enterprise, which utilizes TinyML for some of our customers. But thank you once again for your content and your insights.
Pleasure to
Thank you, Dr. Nick and Tim, for giving us the opportunity. Thank you.
No worries. Thank you. And look forward to seeing everyone in the near future. Thank you.